Matt, you ready? I guess we should get started. A lot of people are already in.
Yep, go ahead, Matt.
And it's 4:10. Hi, everybody. We have a lot of people joining us from all over the world. So thank you for finding the time to join our masterclass. We wanted to present to you, I guess, some stuff that can maybe help you along the way right now with regards to remote production meetings. And yeah, joining me today is Matthew Garrett, where it's 7 in the morning for him. So Matt, thank you for waking up so early. And yeah, I guess we'll really jump right into it. There's no point in waiting. So my background is I've been working in metal AM for the last 8 years now, specializing in critical applications for aerospace, Formula One, energy, medical sector, doing qualifications of production, quality management system, R&D, etc. And Matt, the reason why we felt that he's a perfect candidate to join us for this masterclass is the former COO of Integrated 3D, where he actually specialized in operational excellence and getting the production up to a really good level. And one of the first bureaus that I personally know of, and I've worked with a lot, that were profitable. So we really thought that Matt would be a perfect candidate to exchange with us on best practices in terms of how to track the performance of a production environment, and especially his insights in terms of how a production environment can be done in a way where you track data and actually implement this in an organizational structure. So the way that we're going to continue this masterclass is we're going to have 30 minutes where we'll talk about the theory, and then the actual pragmatic approach of how to do some of these aspects and some of the natural conflicts that occur, and Matt and I will have a discussion about that. So both of us are named Matt. We can call him Matthew, we can call me Mathieu, or just say the guy at 7 a.m. And then afterwards, after this 30-minute session, we'll have a 10-minute Q&A, and it will actually extend a little bit most likely, but for those of you that can stay. If not, feel free to sign up for a personal session on the link that Kate will provide here in a second in the chat, where we've opened up some dates where you can have a 30-minute talk. And you know, I know that there's a lot of people that have personal questions with regards to their production, but also not everybody is an extrovert. I personally know, like, I'm an introvert myself, so I do appreciate that honesty, and I understand how nerve-wracking it can be to ask a question in public. So the first thing that we're going to talk about is cost per part in additive, and why we do things the way we do, because it's very driven by cost. The second thing is we'll talk about the theory behind how to do a production review meeting, and the structure of the participants, how to actually manage these conversations in a systematic way, and the corrective actions that we can take, and how to actually segment those. And then we'll talk about the key takeaways from Matthew's experience personally in implementing these kinds of steps, and how effective and successful he's been with his organization. And of course, it hasn't been all, you know, roses. And so Matt will really share with us his experiences in that. And then we'll have a Q&A to answer as many questions as possible. And if we don't get to your question, I will reach out to you personally per email if you want to leave your email. And my email will be available if you want to send that question through that way anyway. So to understand metal additive, one of the first things that we got to talk about is, in metal additive, it's just another manufacturing process. I know some people get personally excited like I do, but metal additive is a manufacturing process, and manufacturing processes are all about cost. It doesn't matter how exciting the technology is if it doesn't give you a cost advantage. And sometimes that cost advantage is very difficult to quantify, and that's what we're going to be talking about today as well. So when you look at a system that is around $500,000, which is a typical M2 system in production, about 60% of the cost of the parts that you're manufacturing is directly related to the cost of the machine, the depreciation of the machine. The remainder is actually processing steps, the material that's used, heat treatment as well. But what's really important is that a lot of people, for example, focus on the material costs, which are a quality aspect as well, and it's a very complex process. So changing that is not very easy, while not focusing on their internal capabilities. And those internal capabilities are actually responsible for the majority of the cost reductions and the quality that you actually experience. Now, even if we switch to a more productive system like a 4-laser system, which typically costs between $1.5 and $2 million, the risk with that is that the cost of the part is still above 50% related to the machine cost. So that's really important to keep in mind, because if we can optimize the efficiency of the machine, then we can do a lot more to the cost of the entire process than anything else that we could tackle, which is less tangible, but of course it's a lot more important for your competitive advantage. And so in that respect, we will get into that a lot. And so yeah, just to give you an idea of how all of this works is here we have a very simple process flow of exactly what you're doing in production, right? You take the requirements of the customer or internally, right? Keep in mind, this is not an exclusive service bureau topic. You develop a quote, you prepare the data, and then you go into manufacturing and post-processing. Now that entire value chain for a job that takes 20 hours is about 19 days nonstop. And of course, in a production environment, we don't have a single machine. And so that gets extended to 2 to 3 months because of the fact, of course, you have this stop and go process that happens naturally in the production. So when we have this 2 to 3 month process, it's very difficult to use simple accounting principles in order to understand what is your output and your profitability. Because of the fact that by the time that you're able to understand the profitability of what you were doing, it's already been 3 months. And so that's number one, too late. And it's really hard to identify which application and which production batch it was actually connected with. So instead, what we propose is an alternative approach where we actually focus on 100% ideal production environment on a daily basis, on a batch basis, on a part basis. And we actually extrapolate that in terms of a perfect quality or an acceptable quality for what we're doing. So we define that quality metric first, because we don't want to go below that, because of course we can always run systems faster. And then based on that, we try to understand what can we do in order to get it to that 100% ideal. Of course, a very simple approach is like, let's increase the layer thickness of our printing process, right? But that's not usually, the case that we can just do that. And with that methodology, we can then help determine instant corrective actions of what's going on. And by the way, if you're just signing in, which I see more people are joining right now, if you were here for the arts and crafts class, that's been canceled for this week. So I'm gonna ask you to just leave or just sit in and just listen to the rest of the talk. So yeah, when we're talking about the production environment, we're talking about maintaining uptime. And of course, when it comes to scheduling, that's a very simple approach. But what we want to focus on at this instance is to smoothen out that curve so that you're not focusing on getting a lot of orders and then turning those orders out. And then after that's gone, we have to focus on acquiring more projects. We have to smoothen those curves out so that we can actually understand our baseline. So the basic process in the beginning is involved with data preparation, a production queue, and then AM production. And what we mean by production queue is all the projects that have already been completed without actually being launched in terms of production. So let's say that in our hypothetical situation, we have an ongoing project, and that's called project N. The next project in the queue is going to be N+1, then N+2, N+3, and then any other project afterwards is in data preparation. Now, at the end of the production run, project N can have some issues. The parts can be rejected, there can be a breakdown, right? When that happens, the natural instinct that people have is, holy cow, I gotta get this delivered. I'm gonna go to my computer, fix things up, and then try to launch it on the machine. Well, in that time, the machine is not running, so that's inherent downtime. We're also not considering the rejected parts that just came out, which is also a loss in efficiency. And what we should focus on is, instead of trying to rush that through the production, we should actually then just let the next project in the queue, which is project N+1, jump over into production. And then we have what we can now use in terms of focusing time to actually fix project N. Now, project N, what we do is we segment it into two different categories. The first one is, can we fix this on our own, right? And that means, or do we have to talk to a customer? So if we don't need customer feedback, we basically allot a fixed amount of time to the project manager in order to fix the production, and then actually put it back into the queue. So if project N+1 is running and it's 30 hours long, then of course project N can just continue right afterwards. And the queue then looks like project N, N+2, N+3. However, if we require customer feedback, then the turnaround will be significantly higher. And that's because of the fact that the customer has to give us feedback, maybe redesign something, and so we need at least 72 hours. In that case, the queue looks a little bit differently because we have to give a fixed amount of turnaround time for the project managers to actually prepare this new project and then actually bring it back into the queue. So now the queue is a very important aspect because it smoothens out our production. and it gives us time to actually critically think about what we're doing. If we don't have that, it does become a little bit challenging. So that's why one of the first things that we talk about is develop a production queue so that you can then use this in order as a buffer in order to maintain the efficiency of your systems, because remember, as the efficiency goes down, your cost per part will inherently go up, or you will have financial losses. So having said that, when we look at a production review meeting, we divide it, as you see on this graphic on the right, into two areas. There's the administrative aspect of it, which is led by sales, and those are the people that are in contact with the end user of the application, which they do costing. They also do the technical transfer of information for the project manager. The project manager is responsible for data preparation, bringing the entire project to success. And then there's a machine operator, who is the individual that is operating the actual machines. Now, the reason why we divide it like this is because this is a natural structure where the knowledge and the expertise is completely different between all of these steps. But of course, there are organizations that don't have one of these roles, or they have them blended in a different fashion. So keep in mind, we can modify that according to different requirements, but this is the approach that we take. When we then have this review meeting, we actually have everybody on board, and a more complicated version of this review meeting involves an FMEA, which is a topic that we cover in a completely different class. We will actually have a class about that as well. But the duration of the meeting should be about 1 hour. Now, if the group is significantly large, what we would do is we would actually split the groups into two separate categories, be it according to material, according to industry, machines that are in production, whatever. But what we do at this point is we take every project manager and salesperson, and we give them 5 minutes through basically a Scrum kind of approach in terms of IT, where they describe the issues that they encountered, the solutions that they've tried or have applied, and the suggestions on corrective actions that they have, or they say out loud in the group, I need help. And then in those 5 minutes, we brainstorm each individual project, and then we go on to the next topic. And that's, of course, looking back in the last 2 weeks or in the last week of production. In the same time, we then have a group collective action where the production manager takes the remaining time to address midterm goals. And those goals are going to be divided according to capacity, quality, and cost. Now, we'll get into why in a second. But basically, going into the topic of the individual review meetings, what we talk about is that the project is handled by a salesperson and project manager. And these guys have to communicate with the rest of the production team based on their expertise on what is the problem. So the first thing that we should do is define the 0 point. And the 0 point is where we actually talk about the definitions of what we're doing in production. So you talk about the material that you're using, the machine that you're using, and any application-specific requirements that are really critical to quality, CTQs, for this production part to succeed. Then we put that into a group feedback session, and then as we have some kind of an agreement or challenges to address, then that is done offline with the partner that we've selected, which, if you can keep in mind now, when we're doing remote production meetings, the idea is that every one of these people can actually do all of this offline. In the same time, the production manager has a role to do as well, because he's supervising this entire meeting and he's kind of looking ahead. So what he does is he analyzes the individual performance and benchmark of this person that is discussing this. So if John is doing this project on the technical side, the production manager would look into the performance of John with regards to that material, that machine, and those application requirements, and compare it to similar things that they've done in the past. And we have a database for that, and we can share information about that later, but that's not the point of this meeting. And then at that point, if there is no group consensus, the production manager can get John and say, hey, John, Mike is someone that has worked on similar projects, and I would really like for you to work with him because he apparently has really good experience when it comes to this kind of stuff in terms of rejected parts, in terms of machine performance and uptime. So the next thing that we do is we talk about the team review. In the team review, we break down our analytics into capacity, quality, and costs. And that's because we have to identify the most pressing issue for the organization. So sometimes that is capacity, in other words, of people that are turning the machines around, project managers, and machines. And if that's the issue, then we talk about, and we actually first prioritize those issues, and we try to understand whether it's as a result of poor scheduling, as a result of machine parameters not being optimized or efficient, or inefficient machine turnaround. or even consider things like rejected parts and how much time was wasted based on these rejected parts, which we actually calculate automatically. We also take a look at the trends over time. As you can see in this graphic, we have a little bit of that where it shows that the machine capacity losses have actually gone down and the operator lost time has gone up in terms of performance. So what we then focus on is to try to understand what are the general trends and dig into those and actually have a discussion about what will we do as a team in order to improve these things. Then the second aspect is quality, and that's extremely important because, of course, everybody will say that we want high quality. But one of the discussions that I remember having with Matthew is the fact that quality sometimes is a very ambiguous thing, and everybody wants it, but nobody actually defines it internally. We need to have a common understanding of what that means. So quality is broken down into three major aspects, which is breakdowns of the system, which happens a lot, right? And this is usually due to process understanding or lack of, machine calibration or poor quality in the systems. Minor stops are a result of false data preparation, which then result in too much manual intervention in the process, and it actually occupies the machine operator's time. And then specifically rejected parts, which is again a lack of process understanding or poor communication of technical requirements between the project manager and sales, which leads to nonconformities and rejections in production. And finally, we have costs. The reason why we mentioned that last is because, of course, cost is something that we're constantly driving to improve, but cost is usually an end result of improvements based on capacity and quality. And of course, sometimes those costs are very significant, and we have to understand what is our primary driver of cost and how to reduce those. Now, that is usually because of underutilized systems, rejected parts, again, inefficient machine turnaround, but sometimes there are inherent losses that we cannot fix. And when we have those inherent losses, the production manager has to take a look at what is going on and isolate it according to the material, the type of application, or the machine, and make a strategic decision on whether we should adjust the pricing for those kinds of applications or materials, or actually abandon doing those kinds of projects, right? Because they take, for example, too much overhead time. If we have smaller projects that are running 15 hours on a regular average, then every single time a machine operator has to turn the machine around. And that takes as much time as a job that takes $200. So maybe we should actually say no to those projects or charge twice as much in order to consider the time of the limited capacity that we have in terms of operations. So every one of these topics, we're actually going to be getting into more detail in the masterclass because you can imagine that's a lot to discuss. But I really wanted to hand it over at this point to Matt, who's actually going to discuss the practical aspects of this project review meetings. And and really kind of tell us of like, what are the pain points in terms of developing this kind of a strategy in your organization?
I like this topic a lot because at i3D we were faced with a challenge early on to figure out how to best organize our process and communicate effectively, because our offices were split between sales and the operations facilities. While that it was a blessing from maybe just an operations perspective to not have sales right coupled with the operations workflow. It presented a lot of challenges in perspective and making sure everybody understood each other. So we were presented with that challenge early on, and what came to the real focus was that you kind of have opposing forces and objectives in your work group. You have sales, that makes commitments to their customers. They've got timelines. They've got a frame of quality and delivery, and the challenge of managing those customer expectations. You have operations that's kind of broken up into the engineering, production, finishing, to shipping, and their objective is to run things smooth, make sure that there's no hiccups, and that you're working as efficient as possible. Then you have your quality aspect. It's another opposing force, that is one objective, and that is to meet all requirements. And then, even finance is another force in that. So I think that early on our emphasis was that we've stuck on communication. We've all we've all latched on to communication. It can always be improved, and over communication was our original attack on this problem of trying to bring perspectives together. And while communication is certainly an important aspect, what I found was that communication would come in with emphasis on specific objectives. Sales would communicate around a system because they had a deadline to meet or an expectation of the customer to manage. So what I think is really, really important in making sure that you're having effective review meetings is make sure you define your process. The process of, how a job step by step goes from, a prospect and moves through the whole system. It's important for you to define that so everybody understands the steps that are value add to the product. And then understand the roles of all the participants. And so when you organize a meeting, make sure that the topics are structured and that everybody understands what their responsibility is to bring to the table. Another thing is in your meetings is allow for a limited discussion from all participants. So you've got to put some kind of time frame on it. We got to get to the point. We can't let these things drag on forever. It also forces kind of preparedness. And I like to emphasize a risk-based discussion so that you're looking at what risks are presenting themselves and how to mitigate those risks. Then all perspectives should weigh in on the final decision. And then the most important thing is assigning actions. If we finish a meeting and there aren't assigned actions to individuals to take care of mitigating these risks, then we kind of fall back into the line of business as usual. So, and another thing I think that we learned over time that is important is consistency. It's very, very important to be consistent in the way your big meetings are prepared, conducted, and closed with actions. So that's my real take. One of the takeaways, I guess, from Matt's presentation that I would also emphasize that took some stumbling before we realized was that a queue. You should move on within your queue. If you have a queue and something goes wrong, you tend to put a lot of resources towards attacking that issue. That's an incredible drain on resources. It's a distraction and disruption to the normal workflow. And then you have multiple jobs and multiple issues that you're dealing with rather than that one specific one. So you pull a problematic project out of the queue, continue on with the other one. It lets the work flow, and that way it puts you back into your structured process to make good decisions on how do you attack the issues that are presented.
Hey Matt, I got a question for you. When you're talking about prioritizing, these issues, how did you manage to have some kind of loose metrics in the beginning, I guess, when you're getting started with this in terms of rejections and criteria? One of the things I mentioned is the duration of the value chain, right? And you can't really use bookkeeping in terms of figuring out what's going on. So what are the things that you look at? Do you just focus on the things that just kind of pop up in front of your eyes in terms of production constraints, or was it like a one-on-one project basis and then you realized this is not effective and then you started pulling up some numbers? What kind of numbers did you pull up?
Yeah, I think at the beginning, yes, there was a lot of I would say gut feelings that were applied, and again back to the opposing the opposing forces. Sales was looking for meeting the commitments and the timelines. Quality is looking for all the quality check boxes to happen, and operations is looking for smooth movement through the process. And so at first it was a lot of I think gut reactions or reactionary behavior based on who had a stronger force, because of if a customer's barking about the time for delivery, then all bets are off on smooth operations. We need to focus every resource we have on this. And so, but you can imagine that's a very disruptive way to organize. It's very reactionary. And so over time, we settled out, and I think the emphasis was on, we have to slow down because we have to make good decisions. One event with a bunch of bad decisions on it, certainly the magnitude grows. And so as we got slower and more defined in our process and our decision making, we certainly, not that we didn't have issues, but we could work through them a lot more effectively. And then we could start building metrics around them.
Mm-hmm. I actually like what you said as the last bit right there, which is slow down, right? I remember a lot of times when we were implementing something with you, the discussion was, don't rush, but slow down, right? Which is, I think, a very counterintuitive aspect from the perspective of we're behind on schedule, and so we can't do that, right? And that's where I've seen a lot of mistakes happen, right? Can you talk a little bit about that, and how that maybe was a lesson learned for you guys?
Sure. Yeah, I think that I had an amazing work group where we would put in all kinds of crazy hours, come in the middle of the night, even sleep at the shop if we needed to make things run, or make timely output. But the issue was that as the focus was just on that timeline, we weren't considering all the other aspects, and so it's chaotic. It becomes if that's your only emphasis, then you tend to make decisions that affect all productivity, not just the one that's the issue. So it's kind of cancerous. It kind of grows out through your whole operation. So definitely that is an aha that you need to set something aside that's causing a conflict, and let the rest of things flow, so that you can then on a sideline figure out what the best approach is for the issue at hand.
Mm-hmm. Yeah, there is actually a really cool question that came up from somebody. Isn't it possible to use the operation management tools like CPM when planning the machine operations, right? And I think we've had a lot of discussions about that as well, which it's really difficult to do that, because when you're looking at planning operations through tools like that, what you're talking about is you're setting up jobs, right? That just go, one job starts on Monday morning, ends on Tuesday afternoon. So then we launch the next job, and on and on and on. But one of the aspects that we don't consider in all of that optimization then of scheduling is the resources that we have at hand, which is the first challenge is how many people are in the facility to actually turn that machine around? Because if you have, let's say, 5 systems and one person doing it all, you don't want the machines to be stopping at the same time or within a certain window, right? Because that one individual has to do all of those steps, as an extreme example. The other, invisible waste, as we call it, is the fact that our parameters are not optimized, right? So a job that is starting on Monday morning and ending on Tuesday doesn't take into consideration that it could actually have ended at Tuesday morning, because if we would have optimized those parameters. So CPM in those kinds of situations is really, really lacking, and something that we don't really quantify, like the cost benefit analysis in terms of the opportunity cost that we're losing. And then of course there's the last app, right? We don't talk about the 4 days that were lost in efficiency, and then give that to somebody else to pay for, because of course, that's not their responsibility. If you have 15 projects running in a material, you can't just say that first customer has to deal with that, right? Or how do you book that time?
Right. With you've got a lot of questions in that lineup. But
that was a lot of questions. Yeah.
so reeling back,
just answer which ones you feel like it. Which ones make you look good?
I'm gonna emphasize that I have to say that we were wrapped around the axles for a long period of time on the fact that we had to get this product through. This product needs to hit the shipping and hit the finishing end, and so that jump on it and all resources attacking while machines are waiting, while other things are not being taken care of, while things are being pushed back or bumped in the queue of engineering. All of our resources would go towards that isolated problem. And then when you step back and look at it, you look at all the interconnections that one problem caused, because you didn't set it aside and have a defined process for inserting it into the queue. That disruption is massive, and I think we've all fallen victim to it because we're trying to manage the expectations of customers, but it's a huge inefficiency, and it spreads through all the aspects of the operation, definitely in engineering, because our engineering time, I think, is kind of a hidden cost. As long as the machines are all running back to back, then we think we're efficient, but there's a lot of inefficiencies that can occur in the engineering queue, and we kind of we eventually started defining the engineering queue the same way we did with our machines. We had a backlog, and we, if a problem arose during a development of and building of or setting up of a project, then it was pushed out of the queue, and we moved on so that we could still meet the timelines out of engineering. So I definitely think that's why I emphasize defining that process and understanding what the actions are when you run into those issues.
Matt, by the way, we got
machine stuff, but
yeah, you can keep going, but I just want to add this question because this is like so spot on. So 2 questions came up. So in continuation of the customer priorities, how do you number them, right? And there were some suggestions based on number of volume of projects offered or price value. And then the second one was, do you believe that logistics automation, auto machine downloading, is going to be used more in the near future? I think I understand those questions. I'm going to try to kind of tackle it, and then you can throw everything in that you want, because I think it's just a good transition. So I think that when it comes to automation, the things that people struggle with are something that people are struggling with on the manual side, right? When we use our software Optimal, like, we have a prioritization of issues, and automatically when you suggest something like that, there's a lot of pushback, because it goes, how do you know what my priorities are? And so we've actually had to write those algorithms in a way that all of the inputs that people think of in the context that they normally like to think of, like, for example, machine hourly rate, or operator costs or powder costs, are able to be input there. And then you decide according to what your priorities are in terms of capacity, quality, or costs, right? And then if you have that, then automation naturally comes out because of the fact that you've defined what are your priorities, and you can change them dynamically. So if that is your concern, you can prioritize, a part that is higher value, right? But of course, at a certain point, you don't have those anymore. So then what is your next focus, right? And this is a constraint problem. And what's important is not to dictate to users how those constraints are defined, because they have their own way of looking at it, and they have their own strategic priorities. So what we do is we offer those tools, and then they can use whichever one they feel comfortable with in terms of, my most important priority is capacity, my most important priority is costs, my most important priority is profitability, or I'm just limited on the number of people. And so I'm not going to hire other people. I'm going to work with the ones that I have and say no to certain work. It's very dependent. And so absolutely the automation is possible. I think the challenge has been is defining that automation in an efficient way that, the users are relying on the metrics 100%. And then the metrics are defined according to their needs. And so we've done, I think, a pretty darn good job of that from the experience from the users. But I think, that automation at that point then turns into, we can have something like an additive industry system, which has this entire value chain. But of course, the more things you integrate, just like the manufacturing experience in additive, the more things you put together, the more things can go wrong. And it's all tied into this one thing, right? Because if you're printing and then doing the heat treatment and doing all these steps, if anything goes wrong, at the end, the project is scrapped. And so that is a huge loss of efficiency of the systems. Just again, going back to you, like you're talking about prioritizing your efficiency and your resources. And there's that bookkeeping approach that you guys were doing as the back of the envelope calculations. And then, go ahead, add anything you want to that. And also the machine efficiencies that you were talking about, or the discernment between the different systems.
Well, I guess as far as addressing the automation, I guess unless you're in the business of developing automation systems, you kind of gotta work with what you have in front of you. I would say that I would not wait for an automation system to save the day. I would focus and look at the resources and capabilities you have, and look at developing all the efficiencies you possibly can with the tools at hand. We all definitely. I like to be inventive in my mind, and I'm always thinking that there's got to be a better way to do things, and I agree with that. But in the reality of day to day, we need to focus on how we can be as smooth and efficient as possible with what we've got. I think the other question was, where did those go? Oh, the continuation of customer priorities. I can't share all the details of how we at i3D might have came up with strategy there. I think it's we're always faced with the struggle of what takes a higher priority. I'd say that in that system is kind of a dynamic system. One thing with this new technology that we're all dealing with, there are not everything is a defined input and output, and so we're faced with a lot of challenges and dynamic moves that we have to make. Certainly, we looked at what the value of any given project was, and what the potential continuation of that project was. What was it a project, and is it a project that can is a reoccurring? Will it produce into more of a production based longer term activity, or is it just a prototype or one off? And you have to set those priorities that to emphasize the things that are going to be more sustainable for your business.
I think that's a really good point, is that a lot of people are struggling with getting projects onto their systems, right? Because it's still a very expensive technology. Let's be real about that. And on the other side, they get into this valley of, I'm just going to do whatever, and then they don't specialize, which is a really big problem, where companies are able to manufacture everything, but then they're not able to deliver something from the beginning to end that is a more complex application because they haven't been able to develop that expertise. That's I think a really big struggle, and that's because they're trying to snip out their area in the market. And then the second thing is that they're not considering their utilization, right? Because you might get a project where a customer will come and ask you something specific like, hey, I need you to build this in a certain parameter set that is not efficient. And they're like, yeah, this is great. I'm utilizing my systems, but inherently when they're using those slower specific parameters, then their efficiency is down and their margins are very slim, right? So it is actually, not just important to, first I would say, first and foremost, if you have the luxury to prioritize your efficiency, right? And that's kind of what we focused on a lot in terms of this class and what we've done in our work. The second aspect is you do actually have to have some kind of a VIP lane for those customers that are in the future going to be the ones that you're going to have a relationship with and you can do some really wonderful stuff. But you got to really kind of keep your eye out, on for those kinds of things. Have a vision, sure, specialize. Don't do every material because, changing powder, like who's going to pay for that, right? That's inherently, you're literally staying busy to lose money. And I think that the overarching theme of that is opportunity cost. So when we analyze metrics from capacity, quality, and costs, we're talking about, how could you have it at 100% efficiency for those days? But also, what is the opportunity cost of doing that project versus doing another project, right? And if you're running, let's say you have 2 parameter sets for titanium, 30 and 60 microns, and a customer requests from you to do a 30 micron project, well, you got to calculate your opportunity cost of what could I have done with a 60 micron process in that case. Those kinds of analytics we deliver all the time, right, with Optimal, and that's, I think, extremely important for people to have a bigger strategic picture in terms of lighthouse customers and also applications and then also efficiency, right? So if you maximize all 3 of those, you can answer that question in many different ways. If you have margins to play with, then definitely focus on some specific customers, but yeah, it can be very problematic otherwise. And of course, everybody has to share that vision, like you mentioned. You have to understand the process, and I think everybody in the organization has to have a common understanding of what quality is and what, for that organization, and what the production bottlenecks and what the production focus is. So in other words, conveying that vision to your team so that they can make those decisions on your own and you're not bogged down. And then maybe even focus on automation. So I just realized we're already at 5 o'clock or 8 o'clock your time, Matt. Thank you so much for joining us. I guess the one thing is to mention, like, we're going to send you guys out an email just to ask you for some feedback, in terms of like what kinds of times you'd rather have for the next session. And then the other thing is that we do have the next masterclass coming up on Wednesday on the 20th at the same time, for the sake of discussing continuous improvement and then how would you actually change things in a highly regulated environment with someone that has done a fantastic job in that. I'm gonna just send it out, send out the link to you guys right now. And yeah, and if you have any other questions or if you want to book your session, go right ahead. And then we'll be speaking with Gianluca. Matt, thank you so much. Thank you so much again. You're the first.
Thanks for
how was it?
Participants.
Thank you.